All right, so this week we are sticking with our categorical propositions, but now we're going to start doing a little bit of categorical logic. And by that, I mean we're going to start evaluating some arguments. We're going to be focused this week on immediate arguments, which is just one premise, one conclusion. So we have one categorical proposition as our premise and one categorical proposition as our conclusion. Later, we're going to move on to mediate arguments, and those are arguments with more than one premise. When it comes to categorical logic, we're going to be evaluating categorical syllogisms. So that's two premises, both of them are categorical propositions, one conclusion, that's also going to be a categorical proposition. Later, when we start to do propositional logic, we'll be focusing entirely on mediate arguments, and they're most likely going to contain way more than just two premises. All right, so let's go over some mediate arguments in the modern interpretation. So remember, when it comes to our categorical logic, we have two different interpretations, modern and traditional. Modern does not make an assumption about the existence of objects, whereas traditional does make an assumption about the existence of objects. This is a huge difference between the interpretations. And right now, you're probably like, I still don't understand what that means. You will understand what this means by the end of this week's videos. But let me do just a preliminary teaser of this. Last week, we learned how to draw categorical propositions using Venn diagrams. Now we can use these Venn diagrams to prove validity or invalidity. And we're going to do it right now with immediate arguments, but we're also going to be using these Venn diagrams when we go on to mediate arguments, the categorical syllogisms. So how do we do this? You're going to have one premise, one conclusion, and you just draw the Venn diagram of the premise, you draw the Venn diagram of the conclusion, and you see whether the picture of the conclusion matches the picture of the premise. And that might not make much sense now, but trust me, I'm going to unpack that in these videos. But let me show you an example here, actually two examples, and I'm going to draw along with you so that we're all on the same page. So first example, all dogs are mammals. So I draw my Venn diagram, and I'm assigning this left side D for dogs, and the right side M for mammals. Now, I'm going to draw a Venn diagram for the conclusion. All right, draw that conclusion. This left side is still going to be called dogs. This right side is still going to be called mammals. Now, I have to fill in the Venn diagram with the content of the premise. So, all dogs are mammals. How do we draw that one? Well, what is that statement saying? It's saying that everything that's a dog is going to be a mammal. So there's going to be some empty space in my Venn diagram, some space that there's not going to be a single member in that area. And which area is that? It's this one. So I shade in as best as I can on this PDF or this PowerPoint, this section of the Venn diagram. Why? Because it's empty. There's nothing in there. All of the dogs that exist are going to be in this little middle part because they're going to be both a dog and a mammal. But then my conclusion, so all mammals are dogs, that's saying something different. It's not saying that everything that's a dog is a mammal. It's saying that everything that is a mammal is a dog. So I'm going to shade again because it's making this claim that there's some empty space in the Venn diagram, but it's not that same section. It's this one on this side is where I'm shading in. Why? Because the statement is saying that everything that is a mammal is a dog, which means there's not going to be any members here in this area of just mammals. Everything that's a mammal is going to be in the middle part that's both a mammal and a dog. Now, I know you're thinking, that statement's false. I talked about that a lot last week. Doesn't matter. That's what the conclusion is saying. So that's what I'm drawing. And again, don't let the semantics deceive you. Don't get hung up on the semantics. All I'm doing is going by the syntax. That's how I'm going to shade. Now, look at these two pictures. This conclusion has this area of the diagram shaded in. For the argument to be valid, the premise would also have to have that exact same spot shaded in. And in this case, it's not shaded in. So I can conclude by just looking at these pictures that this first argument is invalid. The conclusion is not contained in the premise. The conclusion, it does not match the premise at all. And I don't want to say that for an argument to be valid, the premise and the conclusion have to look the exact same, because in some cases, they're not going to look the exact same. I will show you one of those arguments later on, I think near the end of this section. But let's look at this second argument. I'm going to actually, instead of try to draw this again, I'm just going to use these two. I'm going to assign D to human and M to women, because like I said, I can assign any letter I want, and I don't want to go through the problem of trying to draw it out. So some human are women. How do I draw that one out? What I'm saying, this is an existential statement, which is supposed to be asserting the existence of something, and we'll get back to that in a minute. But something's a human, and that something's also a woman. That's what that statement is saying. So I draw my X in the middle, because that's that one thing that's both a human and a woman. And then I go look at my conclusion. So some women are human. And I say, all right, so that means there's something that's a woman who's also a human. And I draw my X there in the middle. Look at that. The conclusion contains an X in the middle. And I look at my premise, and it has an X in the middle. In this case, the diagrams are exactly the same. When the diagrams are exactly the same, you immediately know that it's valid. But like I said, sometimes you're going to get cases that look like this, where this is shaded in. This kind of argument with this premise and this conclusion, still valid. Why? Because when I'm looking for validity, I'm looking to see, is the conclusion contained in the premise? Here, the conclusion is just an X in the middle. Now, the premise contains more information. This premise is saying something that it's empty space on this side, but something exists here in the middle. And you might be thinking, how am I going to draw a diagram like that? None of the diagrams we've currently covered look anything like this, where it's shaded and an X. But there's going to be some arguments where the premise, the statement will look like that. And you have to keep in mind, it doesn't matter if the premise contains more information. What matters is if the conclusion is contained in that premise. Here, the conclusion is just that X in the middle. Since there's an X in the middle up here, this type of argument would be valid as well. But I know you're thinking, how do I draw that premise? Like, what does the premise look like that I'm making that kind of drawing? And you'll see here in a couple minutes. S, P. All S are P, but I'm going to go ahead and shade that area in. That's how I would draw that A statement. How do I draw an I statement? Some S are P. Go ahead and slap a little X there in the middle. And this is how you would draw it in the modern interpretation. Now let's look at some semantics. Let's consider this argument with its semantics. All dogs are friendly creatures, therefore some dogs are friendly creatures. This seems like a valid inference. If everything that's a dog is going to be a friendly creature, then certainly there exists one thing that's a dog that's also a friendly creature. But under the modern interpretation, this argument is invalid. Why? Because we look at the diagrams, we look at our conclusion and see there's an X in the middle. So I go look to my premise to see if there's an X in the middle, and there's not. Since the premise does not contain that conclusion, this argument is invalid. But to us, when we're looking at the semantics, it seems so clearly valid. So this is just one flaw of the modern interpretation, the flaw that boils down to this not making an assumption about the existence of objects. When we get a universal statement like all S or P, the modern interpretation is not making an assumption about whether or not there actually exist dogs or whether or not there actually exist friendly creatures. We're treating it in the pure syntax form, which is just the shaded area is empty, and anything that would exist, if it does exist, would be here. But since we're not making any assumptions about existence, we don't draw any X's. It's this is it. That's the entire diagram of an A statement under the modern interpretation. So it's invalid, and this seems problematic. All right, we're going to circle back to this near the end when we start talking about traditional, but for now, keep this in mind, this problem. Okay, so in the last little section from last week, they presented you with the modern square of opposition. What's opposition? Opposition is just the same subject and same predicate, but obviously it's going to have different quality. It's going to be affirmative or negative. Those qualities remain the same given an A, E, I, or O statement, but we keep the same subject and the same predicate. So here are the examples, right? All S or P. E statement's still going to be universal negative. We're going to keep the same subject predicate, no S or P. I statement, a particular statement, some S or P, same predicate, same subject, and then O statement, some S or not P. Same subject, same predicate, but remember everything else about these A, E, I, and O statements remain the same. Now under the modern square, we can know the truth value of some of our propositions if we know the truth value of some other propositions. And in this case, if we know the truth value of an A, then we can immediately know the truth value of O. If we know the truth value of E, we can immediately know the truth value of I. And the same thing goes the other way. So if we know O, we're going to know A. If we know I, we're going to know E. But if we know A, we might not know E. And if we know A, we might not know I under this modern interpretation. Traditional interpretation, we can make many more inferences from the knowledge of one of the truth values of one of our statements. But under the modern, because we're not assuming existence, these are the only relationships we can know. Then these are called contradictories. What does that mean? It means that if one is true, the other one has to be false. If one is false, the other one has to be true. So in this case, if all dogs are friendly animals, if that's false, which it probably is false, right? There's probably a couple dogs out there that aren't friendly. Then we know for sure that the O statement has to be true, that some dogs are not friendly. Why? Well, if all dogs are friendly is false, that means that not every single dog is going to be in the class friendly animals. There's going to be at least one, maybe more dogs who are not in the class friendly animals. And that's exactly what the O statement is saying, that there's at least one dog who is not going to be in the class friendly animal. Now, if the statement some dogs are not friendly animals is false, then we know for sure that all dogs are friendly animals is going to be true. And the same relationship holds between E and I. I go over this. This contradictories relationship is the same under the modern and traditional square of opposition. So this exact same diagram is going to hold, whether we're in modern or whether we're in tradition. And when I go over traditional square of opposition, I'll talk more about contradictories. But then I'm going to go into a couple of other relationships that we can for sure know, so long as we know at least one of the proposition's truth values. All right. So now let's go over some more examples of immediate arguments. We have conversion, aversion, and contraposition. This would be a good time to take a break if you want. I'm going to just keep on going now. All right. So conversion. What do we do here? We switch the subject and the predicate. So our premise is just a normal whatever statement we want, i.e. A or O. And then for our conclusion, we switch our subject and predicate. So if we start with an E proposition, we're going to have an E proposition as our conclusion, but our subject and predicate are going to flip. Here's the example. No dogs are reptiles. So that's an E proposition, a negative universal. And then we make this inference, therefore no reptiles are dogs. And that's again, a negative universal. So we have an argument here. Now we can figure out whether it's valid or invalid by drawing those statements. Now I'm not going to draw them all, but I will tell you the relationships between them. So when we do a conversion on an A proposition, we end up with an invalid argument. When we do a conversion on E propositions, we end up with a valid argument. When we do a conversion on I propositions, we end up with a valid argument. And when we do a conversion on O propositions, we end up with an invalid argument. To prove validity, you could draw the diagrams, but you could also just do the counterexample method that we covered in chapter 1. Check out this A proposition. All dogs are mammals. That's true. Conclusion, therefore all mammals are dogs. That's false. And remember, the definition of invalidity is that it's possible to have true premise, false conclusion. And here's that possibility. O proposition, I came up with another counterexample here. Some plants are not carrots. That's true. Therefore, some carrots are not plants. That's false. All carrots are plants. So we have a true premise, false conclusion. Now, it's impossible to come up with true premise and false conclusion when it comes to our E proposition and our I proposition. So in this case, maybe I will draw it. Just like I said, it's going to be really important that we're all very comfortable drawing these. If you're comfortable drawing them, you can skip ahead. But if you're not, check out how I draw it. So first premise here, do D for dogs, R for reptiles. No dogs are reptiles. What's that saying? There's not a single thing that's a dog that's also a reptile. It's a universal, so I know I'm going to have to shade, and I'm going to shade here in the middle because this middle spot's empty because if the thing's a dog, it's not going to be a reptile, so it's not going to be in that middle spot. And if the thing's a reptile, it's not going to be a dog. I'm kind of skipping ahead here because I remember that when it comes to these E propositions, the distribution goes both ways. But let me draw it out anyways. Right again. All right. Venn diagram, dog, reptile. Super important. When you're drawing these arguments, if you put dog on the left-hand side and reptile on the right-hand side for your premise, you have to keep the same for your conclusion. So you can't put an R on this side and a D on this side. That's going to give you a diagram that's not going to reflect the actual validity or invalidity of the argument. So don't do that. All right. So therefore, no reptiles are dogs. What's that saying? There's not a single thing that's a reptile that's also a dog. And spoiler alert, you shade in the middle here. And to check for validity, well, I already know immediately the diagrams are exactly the same, so I know that this argument is valid. Same thing goes for the I proposition, but I won't draw that one. All right. So I was going to say, here's another place to take a break, but I'm going to go ahead and keep trucking along. Of course, you can always take breaks whenever you want. Why? Because this is a video. So, but this is a natural stopping point. All right. Another type of arguments we can form, aversion. So what do we do in this case? We change the quality of the given proposition and we replace the predicate term with its class complement. And there are some technical terms here. Quality, which I defined earlier, but I define it again here in case you forgot, which is affirmative or negative. But class complement is something new. A class complement is a set of objects that do not belong to a given class. And you might think that's just negation, right? So like we have dogs and then we have not dogs. But how do we write that? Dogs and non-dogs. So we have this class of objects, dogs, and then we have all of the other objects that aren't dogs outside of that class. So I'm a non-dog, you're a non-dog, unless you're a dog listening right now. My cat is a non-dog. My house is a non-dog. The state of North Carolina is a non-dog. So all of these random things, I was going to say like a pen is a non-dog, but I don't have a pen near me. Anything that's not a dog, it would be in the class non-dogs. So how can we explain this further? Our one circle is an S. Everything that's a class complement of S, non-S, it'd be outside the circle. And when we're applying it to our Venn diagram, we can see that the Venn diagram has 4 areas. 1, 2, 3 are within the Venn diagram, but this area outside of the Venn diagram is 4. You might be thinking, who cares about what's outside the Venn diagram? But as we start to draw some of these immediate arguments, you'll see that, yes, we are going to have to take this zone 4 into consideration when we are diagramming our statements. So here's what the book says. If something is a 1, then it's an S and a non-P. If something's in 2, then it's both an S and a P. If something's in 3, then it is a P, but it's a non-S. And if something's in 4, it's a non-S and a non-P. But notice that, like, that matters. Think about the statement I keep using, right? All dogs are mammals. We are talking about this class of objects, dogs. We're talking about this class of objects, mammals. But there's some objects in the world that are not dogs and not mammals, like grass and trees and dirt and rocks in the state of North Carolina. Those would all fall under that 4, in that 4 area of non-dogs and non-mammals. Okay, so aversion, what are we doing again? We are changing the quality. So if it's an affirmative, we're changing it into a negative, and then we're replacing the predicate term with its class complement. So we call the premise averted, and then the conclusion that we end up drawing is averse. And lucky for us, all 4 are valid. So this is easy. If I say, here's create an aversion argument and tell me whether it's valid or invalid, you already know it's going to be valid. It has to be. So let's look at some examples. We have our A statement, all dogs are friendly. And how do we turn that into this conclusion? Well, all is affirmative, so we have to change it to no. That's a pretty easy switch. And then we have our predicate term, friendly. And I don't know why it says non-mammals. Just say non-friendly. Sorry about that. Let's start over one more time. So let's consider the arguments. First, our A statement. We have the A statement premise, all dogs are friendly. We're doing an aversion. So we have all. We want to flip that to its negative because that's affirmative. So that's no. So that's pretty easy, right? Anytime you see an all, you just got to change it to no. Every time you see a no, you got to change it to all. But in this case, we have an all, so we're changing it to a no. And then we consider our predicate, which is friendly, and we just plug in the class complement of that, which is non-friendly. I statement, we have some women are human. So this is affirmative. There's no negations in there. And this one might be a little bit tricky because you might be tempted to put the negation at the front of the statement when you can do this aversion, but no, you can't. Why? Because this is a particular statement. And the only way to write a particular negative is by writing an O statement. So when we have some women are human, like forgetting about the class complement, if we're just switching it to its negation, we would write some women are not human. So that negation would be attached to the predicate, not in the front of the statement. And that really matters because the scope of the negation, it matters. It matters significantly. Okay, so now I know where to put my not, but now I gotta do that class complement of the predicate. We have human, so we just say non-humans. And so our conclusion there is not, therefore some women are not non-humans. Now that one's tricky. It's kind of like a double negation there, not non-humans, but you have to include it. So I always, when I'm doing these kind of problems, one step at a time. First things first, change the affirmatives to negatives, negatives to affirmatives. Then add that class complement or replace that class complement with in your predicate term. So just one step at a time and don't steps, because then you might end up forgetting a negation and then your argument is not correct. All right, E statement, no women are immortal. I have no, so I know I'm going to change that to all. And then I have immortal, so I'm going to end up with this class complement non-immortal. And that's another weird one too, right? Because non-immortal, just think like, why can't I just write mortal? It's always best to play it safe. So just slap that non in front of that predicate term and then move on. Ignore the semantics. So we go from no women are immortal to therefore all women are non-immortal. And then finally the O statement. Some dogs are not service animals. This is a negative because there's that not in there. And with the negative in that case, it's easy. You just take the not out. So we go from some dogs are not service animals to some dogs are service animals, but we got to do the class complement of the predicate. So we end up with, therefore, some dogs are non-service animals. So how do we determine affirmative, negative with A and I statements? For an A statement, the conclusion must be an A, I, E, or O statement. Placing a negation on a predicate does not get you an A, I, E, or O statement. For an I statement, the statement has to be grammatically correct. So placing the negation on the subject is going to get you a statement that's not grammatically correct. So let's go back to this I statement, some women are human. If you wanted to place a negation in the front of the statement, you would get, therefore, not some women are human. Like, that doesn't make any sense at all. So keep that in mind when you're creating these arguments. You need to be sure that you are creating grammatically correct sentences. You can't just slap a not in front of the statement, create a grammatically incorrect statement, and then move on. Like that, we're not going to be able to do the logic, because that's the syntax. The grammar is the syntax, and our syntax needs to be clean in order for us to be able to evaluate the argument. And I talk about A statements here because some students might be tempted to go, all dogs are friendly. They change that to all dogs are not friendly. That's the biggest mistake that I see made with A statements. But notice that all dogs are not friendly doesn't fit into A, I, E, or an O statement. It's a universal and it's a negative. So if it's a universal and a negative, it always needs to fit the form of an E statement. Okay. Moving on. Oh, here, just to show you that, and this is in the book as well, this is their version Venn diagram. So we have all S or P. That's how we've always been drawing it up to this point. Then we have no S or non-P. So how do we do, why is it drawn like this? No S or non-P. That means that nothing that's an S is going to be a non-P. And when I'm looking at my diagram, I see that, all right, if no S is a non-P, I'm going to have some empty space. I know that the S is going to be empty because everything that's an S has to be a P, because there's no such single S that's a non-P, and non-P is outside of that P circle. So I shade in that left-hand side, that area 1, and I see that these match up exactly, so it's valid. So no S or P, or moving on, that's diagrammed as it normally is. Now we look at the bottom one, all S are non-P. That means everything that is an S is a non-P. So I'm looking at my P circle. I'm looking to see where's the non-P, which is outside of the P circle. It's saying all of the S's are outside of that P circle, which means that that middle spot has to be empty. Because if something's in that middle spot, that would be something that's an S and a P, but the statement is saying that all S are non-P, so it has to be empty. Moving on, some S are P, that's diagrammed as usual. And then I look at the aversion, which is some S are not non-P. Treat the not non as a negation. Not non cancel each other out. We end up with the statement some S are P, which is the exact statement that we started off with. And then finally, last, some S are not P turns into some S are non-P. And again, if we treat non somewhat like a negation, we'll see that it's basically saying the same thing, that we have something that's an S that's also a non-P. We look at our P space, we see that it's a non-P, so it's going to be outside of our P circle, and we put that X in that left-hand area of the diagram. So these are our diagrams for aversion. It's really cool, though, that everything's valid, so we don't have to worry about it. All right, here's another time for a break if you want it, but I'm going to move on to contraposition. So for contraposition, we start off with our statement, and now we have to do 2 moves. The first is to switch the subject and the predicate. And the second, and this is really tough, I don't like these either, replace both the subject and predicate terms with their class complements. So the A proposition example, all dogs are friends, flip them. So we get the statement, all friends are dogs, and then add the class complement, all non-friends are non-dogs. In this case, 2 are valid and 2 are invalid. A is going to be valid and O is going to be valid. We'll look at those diagrams in a minute. But I and E are going to be invalid. And just like I said before, we could draw the diagrams and look at the pictures to show, prove invalidity, or we can just come up with a counterexample. So here are my counterexamples. No dogs are pilots. So there's not a single dog who's a pilot. I think that's true. Therefore, no non-pilots are non-dogs. That's false, right? No non-pilots or non-dogs. Like, I'm a non-pilot and I'm also a non-dog. So there are no non-pilots or non-dogs. Nothing that's a non-pilot would be a non-dog, but here I am, a non-pilot who's a non-dog. So true premise, false conclusion. All right, so now let's look at I. Some humans are mortal creatures. I'm going to go ahead and flip my subject and my predicate to get some mortal creatures are human. And notice that that's why I chose the predicate mortal creatures, because if I just said some humans are mortal, that's a grammatically correct statement. But when I flip my subject and my predicate, I end up with some mortal or humans, and that's not grammatically correct. So that's why initially here I add creatures to mortal so that I can, when I flip my subject and my predicate, I maintain a grammatically correct statement. So some humans are mortal creatures, flip them. Some mortal creatures are humans, slap on that class complement. Therefore, some non-mortal creatures are non-human. So it's true that some humans are mortal creatures, and you might be thinking, that's like, obviously it's true, like it's not true because every human's a mortal creature, but that's you sticking your syntax or your semantics in the statement when we can't be doing that. Some humans are mortal creatures is just saying there's at least one thing that's a human and a mortal creature. And since all humans are mortal creatures, of course there's going to be at least one who's mortal. So this statement is true. Now this conclusion, therefore some non-mortal creatures are non-human. This is saying that something exists that's not mortal and not human. And if you don't believe in a God, then the statement is going to be false. If you do believe in God, then the statement might be true. So maybe you can come up with a counterexample, a better counterexample. Let me know if you can come up with a better one. Maybe I'll give you some extra credit. But if you don't believe in God, then conclusion here is going to be false. So let's look at how we diagram these. And notice, look at this one. This one has that area outside of the Venn diagram shaded in. So contraposition, the first row, all diagram the exact same as they have been. Now, second row, let's start with A. All S or P, it turns into all non-P or non-S. So what's that saying? It's saying that everything that's a non-P is a non-S. What's everything that's a non-P? Everything outside of here. But everything outside of here is also a non-S. So we have to shade in this area to indicate that that side is empty. There's nothing going to be in there. I'm going to go to O first because that's easier. Some S are not P, drawn as usual. So some non-S are not some non-P are not non-S. That's a hard one. So remember, change subject and predicate. So we have some S are not P, turns into some P are not S. Slap on that class complement. Some non-P are not non-S. It's a mouthful. What does that mean, though? It means that something that's not something exists and it's not a P and it's an S. How do I know it's an S? Because I'm canceling out my not and my non, treating that non as negation. So saying something exists that's not a P, but it's an S. And so I put my little X there in that spot that's indicating an S, but not a P. Now let's look at these two middle ones that are trippier. No S or P, that's pretty standard. We can flip it and say no non-P or non-S. So what's that saying? It's saying that nothing is a non-P and a non-S. Everything's a P and an S. Everything that exists is a P and an S. So if everything that exists is a P and an S, that means that everything outside of the Venn diagram is empty, that nothing's going to be outside of the Venn diagram. So we're saying that everything that exists is contained in that Venn diagram because the outside of it shaded in means nothing exists out there. That there's nothing that's not a P and not an S. All right, last one. Some S or P, flip them, class complement, we get some non-P or non-S. So what does that mean? There's something that's not a P and not an S. Well, if there's something that exists that's not a P and an S and not an S, then it can't be, we can't draw that X inside of the Venn diagram. But something's existing where it can exist outside of both the class S and the class P. So we draw our X in that area 4, which is outside both of the diagrams. All right, so this E and this I, a little bit more complicated. If you have other questions about it, please let me know.